This is the screencast for section 2.6, example 3. Limits and asymptotes. Miss Larson, we already learned about limits, we already learned about asymptotes. Okay, but we're going to take a closer look at them. We always do. So the graph of y equals f of x over g of x. So numerator function over denominator function. Equals, so this is going to be a polynomial in the numerator and a polynomial in the denominator. And just in case you didn't know, I put off to the side what this mn stuff is. N is the degree of the numerator. A sub n then is the leading coefficient of the numerator. Then m is the degree in the denominator, and a sub m is the leading coefficient of the denominator. So now that'll help us when we read all this information we need to know. So the end behavior asymptote. So if n, the degree in the numerator, is less than the degree in the denominator, the end behavior asymptote is the horizontal asymptote y equals 0. If the degrees are the same, the end behavior asymptote is the horizontal asymptote y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Then, if the degree in the numerator is greater than the degree in the denominator, the end behavior asymptote is the quotient polynomial function y equals q of x, where f of x equals blah, blah, blah. Basically, there's no horizontal asymptote. We actually call this an oblique asymptote. So an oblique asymptote would be found by doing synthetic division if you can, if not long division. Number 2, vertical asymptotes. We already know what causes a vertical asymptote. It's an x value that makes the denominator 0 only. Number 3, x-intercepts. Because Miss Larson is so awesome, she has already been drilling into you how to find an x-intercept. You plug in 0 for y, which also occurs only where the numerator is 0, because 0 divided by anything is 0. Then the y-intercept is when you plug in 0 for x. Again, Miss Larson, you're awesome. You've already been teaching us this, so this is really not new at this point, but maybe we can perfect it in this section. So let's look at example 3. Finding asymptotes. Find the horizontal and vertical asymptotes of that function and then use limits to describe the corresponding behavior of f of x. So similar to the last section, if we have a vertical asymptote, we're going to have 2 end behaviors, and if we have a horizontal asymptote, we're going to have 2 more end behaviors. So let's look at f of x as a function written out better than what the book does. X squared plus 2 is in the numerator, and then x squared plus 1 is in the denominator. So first of all, vertical asymptotes are something we're very familiar with. The vertical asymptotes here are anything that's going to make the denominator 0. Well, that would be, let's see, x squared plus 1 equals 0, x squared equals negative 1. So if I take the square root of both sides, that's the square root of negative 1, so that's imaginary. So there are no values that are going to make the denominator 0. So there are none. Now, horizontal asymptotes, though. The degree in the numerator is 2. The degree in the denominator is 2. Therefore, the horizontal asymptote is y equals, see, the leading coefficient over here is 1. The leading coefficient in the denominator is 1. So that would be 1. So we have a horizontal asymptote, y equals 1. Well, I can tell you what those end behaviors are going to be then before I even graph. Are you impressed? Okay. So now, if I have a horizontal asymptote at y equals 1, I know my graph will level out at 1 all the way to the right and all the way to the left. So I can tell you right off the bat, before we even graph, that the limit of f of x as x approaches positive infinity is going to be 1, and the limit of f of x as x approaches negative infinity is going to be 1. Now let's see what that graph looks like. And of course I checked it on my calculator just to make sure I was right, and without even sketching the graph, I could accurately predict the limits of the end behaviors. The now try problem for example 3 is number 19. So find the horizontal and vertical asymptotes of f of x and then use limits to describe the corresponding behavior. So the vertical asymptotes here, numbers that are going to make the denominator 0, that's none. Only imaginaries will make x squared plus 3 0. I would have to have a negative number that results from squaring an x, and that's not possible because squaring anything makes it positive. So vertical asymptotes, none. Horizontal asymptotes, though, however, let's see, the degree in the numerator is 2. The degree in the denominator is also 2. Since those degrees are the same, the horizontal asymptote is y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator, so that would be y equals 2. So again, without any kind of any kind of graph on my calculator, if I know I have a horizontal asymptote at y equals 2, I can tell you that the limit as x approaches positive infinity, so as we go all the way out to the right, the function's got to approach this horizontal asymptote. So the limit of f of x would be 2. The f of x values approach 2. See, y equals 2. F of x is y. Now out to the left, the limit of f of x as x approaches negative infinity is going to also be 2. I don't know what it's going to look like at this point, but I do know that because this is a horizontal asymptote, the left side, as we go out to negative infinity on the x-axis, is going to approach 2. And of course I checked this on my calculator to make sure I was right, and I was right. The horizontal asymptote is y equals 2, therefore I described my end behaviors correctly.